Okay, we'll take a look at a more complicated kinetic energy problem here. We have an F-22 Raptor flying, kinetic energy of 2.24 times 10 to the 9th joules. So there's my kinetic energy, and I want to know how fast that is flying. So we have kinetic energy is equal to 1/2 mass times speed squared. So the kinetic energy is just 2.24 times 10 to the 9th joules, and that's equal to 1/2 the mass of 38,000 kilograms times the speed squared. So 1/2 of 38,000 is just 19,000 kilograms times the speed squared still equals the 2.24 times 10 to the 9th joules. So when we get the v squared over here by itself, we're trying to find the speed eventually. So we're going to divide both sides by 19,000 kilograms. Right, so that cancels out. So now I get a v squared. It's equal to about 117,895 joules per kilogram. So we need to deal with that joules per kilogram. That just, it's a little odd looking in there. So from the previous work we've done here, a joule is just a newton times a meter, and a newton is a kilogram times a meter per second squared, and all that times a meter still. So I've got essentially a kilogram meter squared per second squared. That's the joule. Now that joule over here, right, was just divided by kilograms. So we divide all of that by kilograms, and those kilograms canceled out. That leaves us with the unit of meter squared per second squared. So I'll rewrite this. Our v squared then is 117,895 meters squared per seconds squared. And so we've got the square of the speed here. In order to unsquare that, we take the square root. So we take the square root on both sides, and we should get now a speed of about 343.4, and the units, since we're taking the square root of meter squared and second squared, we get our units of speed meters per second. So we have this plane flying about 343.4 meters per second, which is going to be a little bit faster than the speed of sound, which is why in the picture here you see this kind of cloud forming here. It's actually showing you the sound waves, right, that are collecting, that it's a little shock wave that it's producing as it moves through the air, in that case kind of going past a little bit faster than the speed of sound.